Good morning to everyone. Today is the second session of the Lightning Talks, and we have 5 talks today. Sara Bolero from IMFN will talk about their deployment there. Jan Hoka-Greg will talk about also how they are using OpenNebula Netera. Carlos from the OpenNebula project will share our experience participating in the Cloud Catalyst project. Kishore from Megan will show us how they build a cloud in a box. And the last talk will be Daniel Molina. And I will share with you some of the development that we are doing in the Panacea project. That's an European project that we are part of it. So we are going to start. Remember, each talk is 5 minutes. We'll have time for questions at the end of all the talks. Thank you.
Okay, hello. I am Sara Vallero. I work as a cloud administrator and developer at the computing center of the INFN Torino. So maybe not all of you know what the INFN is the Italian National Institution for Nuclear Physics, which has nothing to do with nuclear plants. It's just fundamental physics studies. So our data center in Torino is, I would call it a medium-sized data center. We have 1.6 peta of storage, 69 hypervisors, and 1,200 job slots for a total of 200 virtual machines. Everything is managed with OpenNebula, of course. And so our cloud project actually started quite soon. In 2009, we have a cloud in production, and I think within our environment, at least, we were the first really to switch to the cloud. And the main reason at the time was, well, to simplify management of the available resources. So the big customer we serve at our cloud is the WLCG Tier 2 for the ALICE experiment at CERN. We also have another Tier 2 for the BESS-3 experiment in China. And we support computing for upcoming experiments like Panda at GSI or Bell2 at Keck. Another big customer of the facility is the virtual analysis facility for ALICE, which means interactive data analysis for LHC and elasticity. I say a word about it in the next slide. Then we also support medical imaging processing, some smaller theory, local research group, and virtual farms on demand. I also will talk about it in the next slide. So the way the infrastructure is structured, so we have 2 clusters of hypervisors for 2 different classes of virtual machines. So we have the service class machines, which are our pets. So because they provide critical services and they need to have inbound and outbound connectivity, we need to have live migration for continuity of service. And these are server class hardware. And they have no particular I/O requirements. The image repository is shared, and so you can see from the sketch in the bottom, you see in red, is the virtual machine images repository. This is actually this is not replicated, but it's shared among all the host of the 2 clusters. And in green, you can see the situation for the running VMs data store for the services cluster. So this is basically the underlying file system is cluster FS. The volumes are replicated on 2 storage servers and then exported to all the hosts of the services cluster. And then we have the cattle, which are really computational workforce. So it's basically 90% grid worker nodes. And they need to have a very good performance in I/O towards the storage, of course, for data analysis. They are just lower class hardware. And what's interesting in our setup is that in this case, to allow for a fast startup of the virtual machines, the running VM's data store is actually cached on the hypervisors themselves with a custom tool developed in our institute. Okay, so what are we doing with that cloud? First of all, we have developed a toolkit for virtual farm provisioning on demand. Now, yeah, we started quite early, so I think OpenNebula didn't really offer yet all the nice features that I could see in these 2 days. So what we do is we have developed it by hand, a toolkit, which is based basically on vRouters with OpenWRT. We have this elastic, maybe people generally call it floating public IP. Another ingredient is that we provide persistent disk space with the iSCSI data store, EC2 interface, and the contextualization is done with Cloud Init. Then elasticity. So the idea is to have a system or an application that is able to expand and shrink according to its needs. So of course this can work only if you have infinite resources, and it's not completely our case because we always basically work in saturation. But still we have this in place for the virtual analysis facility. So we have the big tier 2 block, which is basically something that you cannot touch and resize. And then we have this medium-sized application that if there is space expands and would shrink again whenever the resources are found to be idle. And this is the only implementation of elasticity we have so far, and is also something we've done by hand. Then there is, let's say, for the next future, a project to build an INFN, well, in Italy, Italian-wide cloud is an INFN project. Mostly, I mean, all other units in Italy are based on OpenStack, but we want to maintain the biodiversity by keeping OpenNebula because it just suits our needs, and we don't need to get more complicated than that. But of course, we need to be able to interoperate with OpenStack, especially for services like Keystone. So there is some work that we have to be done that has to be done with this respect. And finally, we have developed a uniform monitoring interface, both for the applications running on the cloud, some of them at least, and for the infrastructure. And this is based on the so-called ELK stack, so Elasticsearch, Logstash, and Kibana. And our goal would be to develop a very simple toolkit to provide monitoring as a service to the users of the virtual farms on demand or any tenant in our cloud. That's it.
Hello, my name is Jan Horacek, and I'm from Czech Republic. I work for a company named @Netera. We are based on Java and open source software. We are about 150 people in the company, and about 60% is our developers. We have 10 sysadmins, and we do all the stuff with CentOS. And now we have some environment for about 3 years with OpenNebula. What we do is making webs, but it's not only webs. We do content management system based on Java, and then we do something like make product from everything, or something we do in our production. Like we do Soika, that's personalization tool. SmartMeter is JMeter on steroids. It's very good with OpenNebula. It could make a lot of load on web servers, and to use the possibility to start more nodes on OpenNebula. And we have EVA. EVA is a web accelerator. It's based on open source software, and it's in reality it's before the OpenNebula servers. We have OpenNebula for almost 3 years. We use it as VDC, like virtual data center, as VMware, but with some cloudy things, like you could use it for regular VMs, but you could use it for non-persistent machines. We have 8 nodes. It's not that much. It's a bit small if you see some installation. Someone was talking here, but it's useful in this case too. I think it will be useful in 3 instances. We have about 11 terabytes of data storage, 260 images, and about 150 VMs on it. Everything is in production. Small part of it is for internal use, but more than half is for our clients and services for clients. We have OpenNebula running on CLVM. It's not a standard solution, but it's working very well. We are using it for the complete image data store. Like it's used for image data store, but for system data store too. It has some hacks. We have GFS2 for the shared storage, and we are completely separated from the compute nodes. Like you don't have the LVM or GFS connected to the management node. As I said, we use the LVM as system data store. Now it's not that big problem, but in the version we started with 3.2, it was a big deal because it was not supported, and we had to hack the drivers, the original LVM examples. It was only an example at the time. But now we stepped through this year. We had to, for almost 2 years, the version 3.2. But during this year, I upgraded the OpenNebula to the latest stable, and it's very nice. Everyone got the new interface, and everyone is happy with it. Now we are using still the LVM driver for system data store. It needs only 5 small patches, so it's not a big problem to use it this way. We have shared storage on SAS, so it's almost native performance, and the ephemeral volumes are not on local storage. They are also on the SAS storage. Yeah, what I like about OpenNebula is that there is always something you can play with and hack on, because it's very modular. So I have almost everything that I cope with on GitHub. If you take the presentation, there are some links. As I said, LVMS system data storage, it's a couple of patches, but it works well. We are using I/O capping and I/O boosting. It's cool when you have a lot of machines that you have control over, but don't have the image what's going on them all the time. Like it's started logging or started a lot of debugging if the developer turns it on. So we have capping of the I/Os and the CPU, and then we have we are using the C groups for adding more through the OpenNebula external added parameters. So if you look at the presentation, I have a lot of nice small things like DNS per VM. That's not part of standard OpenNebula, and it could be simple. It could be made complicated with talking to the DNS server, but it could be just a cron job that makes the list for DNS mask, for example. Thank you.
Well, hi everyone. My name is Carlos Martin. I'm part of the OpenNebula team. I'm one of the developers. I'm going to talk very quickly about the Cloud Catalyst project. The project is a European research project under the FP7 program. It started in September last year, and OpenNebula is part of the project through the Complutense University of Madrid. And the goals of the project are to reinforce the European cloud ecosystem and the community around it. And more importantly, the main goal of the project is to support entrepreneurs, researchers, software developers to create new cloud-based solutions. And we're going to do this with the Cloud Accelerator Toolbox. This will be a collection of guidelines, best practices, use cases, business model templates, recommendations. This will be oriented for entrepreneurs and people wanting to develop new solutions, but it also will help incubators and similar institutions to help their customers to create new programs around this toolbox. And we have already started working on this toolbox. We did a survey in Cloud Catalyst, and we're going to study the results to create trend reports and study the main motivators and barriers that companies find when they try to use a cloud solution, a new cloud solution. And this will be translated to innovation opportunities that we can offer the new entrepreneurs interested in our results. So for example, I copied here a couple of relevant graphics. As you can see on the left, the main cloud manager solutions, the level of awareness, how many people are already using it. You can see at the top, well, maybe you can't, but it says the most used ones are VMware, OpenStack, and OpenNebula. So open source is highly relevant. That's a good data. As you can see on the right, if, we also can study the appreciation of open source solutions by separating the types of company by years on the market. And we're doing this kind of a study to help entrepreneurs know their target customers. So for example, they will have insight about the target companies. Companies working in banking industry will have different security requirements than companies in education, for example. Or if they're targeting big companies with lots of employees, they will see from our report that these companies appreciate integration with identity managers like LDAP, for example. And if they are going to create a product targeted at small companies, maybe they can forget about that kind of integration and just keep the time to market lower. We have already presented some of these conclusions in the first annual event we had in Bled, Slovenia. And we plan to have more conferences and boot camps. So if you are interested in this, you can follow us on Twitter, LinkedIn. You can subscribe to our mailing list or just ask me in the break. And that's all I had prepared. Thank you.
Hello, everybody. My name is Varadarajan. They call me Rad. I'm from Megam System. And Megam System develops a lot of tools around OpenNebula. And I'd like to explain the reason behind the concept of cloud in a box. And I see a lot of system programmers, platform architects, and a lot of administrators. But there's always a need for a simple platform or something when they really want to use the system. Like what he told about, you just want Hadoop cluster to be launched or just a CRM tool, or we want to get into the job and hide all the complexity around the platform. And that is how we arrived at this concept. And this is a side project when we are working on our PaaS platform. So is this a new concept? No, there are already a lot of other projects in the market. It's not a new concept. But we are slightly different from what is available in the market, mainly because you can see that Ubuntu box, which is based on Ubuntu with their PaaS tools and other things, it's commercially available. You can buy it, and it's almost similar. Like you can spin off virtual machines and do all the orchestration, everything with their platform. And cMicro is a high-performance cluster with Vital core hardware. And that's also based on Ubuntu, and has a similar concept. And there are other things in the market like Nebula. This is OpenStack implementation around that, and it is it's also based on OpenStack, but they have done some modifications to that. And Nimbox is like KVM based. We don't know what is the underlying operating system, but it's KVM based. And Scale Computing is also KVM based, but completely proprietary interfaces. And Nutanix is also KVM based, but completely proprietary. They're all let's say they're all cloud in the box concept, but where is the problem in this is that it's not scalable. You just buy a box and you want something more or something, you have to buy another box, and that's how it is. That's the concept behind it. And also it's not customizable. There is nothing you can tinker around. You just install it and then you start using whatever interface they have built in and start using the system. So where we want to be different is that we want to use OpenNebula as a base. And you want to offer all the facilities what OpenNebula offers in a very easy fashion. We just automate the whole process. So we have everything built inside that, and our automated process installs the OpenNebula, and you have DRBD for your block replication and disaster recovery and these solutions. And we have the Megam, that's our PaaS also built in so that you can launch application from any source repository from GitHub and all that. And we have public cloud plugins also built in Megam so that you can just expand it. It can do cloud busting to Amazon or any of the public cloud infrastructures. and we have the storage built in and a visual data center creator. So all this we are offering as a completely automated platform. You just download the ISO and you start installing it on your bare metal server in a completely over the network. It's an automated process. So this gives an idea how we do it. Is like you take the bare metal server, you download the ISO, you register in the Megam pass, you get your credentials, then you put in the credentials, and it starts downloading all the packages and slowly installs into the computer, into the bare metal server. And we use Cobbler for the automated install of all the packages. And OpenNebula, we don't tamper with it. We just install the way it is. So all the facilities, features, whatever is available in OpenNebula is available here. And if you want, after installing the first base unit, if you want to add more nodes, you just go inside, install plug in the next server in the network, and it automatically guides to the whole process. So as we see that we have the basic facility, when you compare to these particular products, we have the combination of both. Yeah, the best of both worlds. We have the flexibility, scalability, and at the same time, we have the ease of installation. And this will help, even people who are not very highly technical about the whole thing and they want to go ahead using OpenNebula, we feel it will be a great tool. And it's a product which we developed as a part of our past development. That'll be all. Thank you.
So this is the last talk. You may know I'm Daniel Molina, and I'm part of the OpenNebula team. And in this talk, I'm going to show you our work at Panacea. Panacea is an European project that we are part of it. And the main objective of this project is to provide proactive autonomic management of cloud resources. Basically, the idea here is that we deploy a group of VMs, a service, and when these VMs are running, they have to be able to reconfigure, to self-protect, self-heal from inside the VM. So we have to provide an effector to do these actions. So we designed an architecture for this. This is basically the idea. We have a service manager where the users instantiate the services. The cloud manager schedule these VMs and take the resources needed. And then from inside the VM, we need to contact the cloud manager. So the VM have to be aware that he's part of a cloud. He has been deployed in a cloud, and what are the VMs that are part of the services, the service also. When the VM knows these things, he will be able to shut down new VMs or start new VMs based on a prediction model that is built using a machine learning framework. This is not the part that we are developing, but we are basically providing the mechanisms to self-protect, self-reconfigure, and self-optimize the service. So this architecture applied to OpenNebula would be, the cloud manager is obviously OpenNebula. One flow would be the service manager, where you can define several VMs and dependencies between different roles. And then we have the one gate component. We developed this component when we included the elasticity rules in one flow. We realized that we needed a way so that the VM can provide information of the application that is running inside the VM. So the VM can push monitoring to OpenNebula and apply elasticity rules based on those values. So for this project, we used this component and we extended it. And now using one gate, you can ask, I will show you in the last slide what are the available actions, but this is how it looks like. One flow on top of OpenNebula, and then you have one gate running in your infrastructure. And the VM contacts this server using a token provided by OpenNebula, and is only able to retrieve information of itself. So this is the development we did for the project. We developed a small command line interface that is injected in each running VM. And the VM can retrieve information of itself. It's like one VM so. Can push information to the VM. And also, if it's part of a service, it will get information of all the VMs of the service. Even the VM can share information. It can update one of the templates of a running VM and retrieve it in another one. And even the VM can scale the service. So I need 5 more workers. So the VM can send this action to OpenNebula using one gate. And basically that's all. So we have finished with the talks. So you have any questions for any? Do you have any questions for any of the talks? Are you hungry? Okay, then one talk.
It's for Sara Valero. What is your experience with GlusterFS? Do you like it? Is it working properly?
Some smaller storage where for some reason it would start to fill bricks basically randomly. So some brick was filled and some other were empty, so it was a huge mess. Don't know why. Maybe it was some misconfiguration because we left all the parameters more or less in the default mode. I don't know. But apart from these little accidents that happened recently, I would say we have no problems. Yeah.
Anyone else? So we are done. Burn. Lunch.